welcome back to Chemistry Videos. My name is Clarissa Sorensen-Unruh, and today we're going to talk about exponents. Exponents. All right. Now, in previous, pretty much throughout chemistry, and maybe in previous lectures that you've looked at, we talk about scientific notation. And scientific notation has this general look of kind of some number of significant figures times 10 to some exponent. And that exponent is positive or negative. It's positive if the number is larger than 1. And it's negative if the number is smaller than 1. And really, we could be more specific here, because between 1 and 0, you would actually use, between 1 and 0, sorry. Between 1 and 9, you would actually use an exponent that's 0. So it's actually got to be larger than probably 10 and smaller than 1. Larger than 10 and smaller than 1. There you go. If we were going to be really super specific about that. Okay. Having said that, if we get a number like, let's just make up something like 1.23 times 10 to the negative 5th versus 1.23 times 10 to the positive 5th, okay, the way you plug this into your calculator is only differing in the negative versus the positive. So the way you would plug this into your calculator is you would search your calculator, because it's a scientific calculator, for a button that says EE or EXP. Or sometimes, if you get weird calculators today, it says times 10 to the x, which is a little weird. Okay, not 10 to the x, times 10 to the x. Okay. So what you're going to do is this button, whatever it is, actually signifies what that last button says. It's only confusing to have this last button in that there is a 10 to the x button, which is inverse log base 10. But let's keep it simple, right? What this button means is it means times 10 to the whatever. Okay? So what you need is some number times 10 to the whatever. So what you need to do is you need to plug in that beginning number, and you need to plug in the exponent. Okay? The way you'd plug it in here is you'd put a 1.23, and then you'd hit that button, and then you would put 5, right? Over here, you would do the exact same thing, right? You'd have either the EE button or the EXP button or the times 10 to the x button, and you would get 1.23. And since this exponent is negative, you would have to hit the negative button first. The negative button might look like that. It might look like that. It is not the subtract or minus button. It's different, so beware. And then you'd hit 5. Okay? And that's how you would plug in scientific notation. Okay? This is very different than if you had some number to the power of something else. This kind of idea of a number times 10 to a power is very different than just the number to the power. Okay? So in that case, what we're going to do is we're going to talk about that. Okay? And let's just go ahead and erase everything here. All right. And have a moment of clearing our heads for what comes next, because it's a little different. In terms of exponents, right? You can have exponents where you multiply a number times 10. That's the scientific notation. And as I've said in a previous video, if you have a positive exponent, then you're multiplying it times 10 that number of times. And if you have a negative exponent, you're dividing it by 10 that number of times, because a negative exponent means that the number goes on the bottom. Okay? This is very different than if I have just x to the y. All right, so what does this mean? If I had 3 to the 4th power. We know from basics, the basics from basic math, that what this means is you are going to multiply this number by itself 4 times. Okay, so 3 times 3 times 3 times 3 is different than 3 times 10 to the 4th, which is 3 times 10 times 10 times 10 times 10. Totally different numbers, okay? So the way I'm going to plug these in, we already know how to plug this one in. We're going to hit 3 and then EE or EXP or times 10 to the whatever, 4. That's how I get 3 times 10 to the 4th, right? To get 3 to the 4th, I'm going to find a button that looks like an up caret, or sometimes it looks like X to the Y or Y to the X. Okay, this button is the power button, and it allows you to bring this number to the power of 4. Okay, so that's how you would plug in that one. That's how you plug in that one. Okay. All right, now, the important thing about exponents is that when we're doing complex calculations, you actually get an idea of what your number should be before you actually get it on your calculator. So let's talk about that. And this is particularly true when you're dealing with scientific notation. Let's do a quick dimensional analysis problem, right? Let's say that lake, no, let's not say a lake. Let's not do a lake. Let's say that the volume of a block, okay, and that's kind of a cubish type block, but let's say this volume is, what do you think? 1 meter cubed? It's a pretty big block compared to what I drew. And let's say that we want that in nanometers cubed. So calculate, the way this would look, by the way, is calculate the volume of a block measuring 1 meter cubed in nanometers cubed. That might be awful English, but you get the idea. Okay, so sorry. Okay, so in terms of looking at this, we know the conversion factor between 1 meter cubed and nanometers cubed, right? Okay, so let's do that. 1 meter. We at least know what the conversion factor is between meters and nanometers. We know that in 1 meter, there's a billion nanometers, right? 10 to the 9th. And your book often has it in terms of the base unit, so they might say it as 10 to the negative 9th meters equals 1 nanometer. Okay, so they might flip it. I tend to use kind of something along the lines of the things we learned at some point. We learned that there were 100 centimeters in a meter. We learned that there were 1,000 millimeters in a meter. We learned that there are 1,000 meters in a kilometer, so on and so forth. So just FYI, I tend to use that. I use the positive expression. Okay, so here, if I know it's 1 meter cubed, the important thing, the volume of this block, and I know I want it in nanometers, then I'm going to actually spend some time doing this, right? So I want to find out how many nanometers there are in 1 meter cubed. Well, that's fair enough. Let's use this conversion factor. In every 1 meter, there's 10 to the 9th nanometers. But you may say to yourself, Okay, does 1 meter cubed and 1 meter fully cancel out? And your answer to that should be no, it doesn't. Okay, so when you cube this, and people like to do this a lot, don't be that person. Okay, you can't just cube the lovely units and expect things to be all hunky-dory, right? If you cube the units, you better be cubing everything, right? So there you go. You got this. Now, how in the world am I going to put that into my calculator? Well, easier than putting it into my calculator is to remember some basic things about exponents. All right, so let's talk about exponents for a moment. Okay, you could say, let's do this. Let's do 3 scenarios here. Right? All right, in these 3 scenarios, you're asking yourself, actually I'm not going to erase anything. You're asking yourself, what do you do with these powers when you have the same base? What you learned is when you have the same base and you have these, you have them multiplied by one another. So x cubed times x to the second, what you do is you add those 2 exponents. So this would be x to the 3 plus 2, which would be x to the 5th, okay? When you have x cubed and then have that squared, just like we're looking at, what you do with those 2 powers is you multiply them. So this would be x 3 times 2, x to the power of 3 times 2, which is x to the 6th. Awesome. When you divide exponents with the same base, then you subtract those 2 out. So this would be x to the 3 minus 2, which would be x to the 1st power. Okay? So which of these processes am I going to use? I'm going to use the one that looks like what I got, right? I have 10 to the 9th times the 7th, or 9 times the 3rd, which is the same as kind of saying x to the 9 times the 3rd. Actually, I should put 10 here since that's actually the number we're dealing with, right? And why am I just looking at the 10 here? Well, 1 times that is going to be the same as that, whatever it is. And 1 times 1 times 1 is 1. So I don't have to divide anything out. X to the 9 times the 3 would be x to the 27th nanometers cubed, right? All right. Now, let's say I had x to the 27th nanometers cubed, and I wanted to know what that was in millimeters cubed. Okay. Let's give ourselves, actually, let's just do it underneath. I feel like not like erasing right now. Let's do it up here, actually. Let's do x to the 27th nanometers cubed. I want to know what x to the 27th nanometers cubed is in millimeters cubed. Okay, well, how am I going to do this? Well, what I know is I know that in 1 meter, there are 10 to the 9th nanometers. And I know that in 1 meter, there are also 10 to the 3rd, 1,000 millimeters. And this is all from your book, right? Okay, so now what am I going to do with this? Well, what I'm going to do with this is, and I don't necessarily know the conversion in between nanometers and millimeters, and I don't really care. I don't need to know that. I just need to know the conversion between those 2 units and meters, right? That's all I need to know. Okay, so I have this set up here. I have it set up correctly so that I have nanometers in a place where they can cancel out. I have millimeters in a place where they can cancel out. My life is fantastic. However, what have I forgotten? The question is, what did I forget here? What I forgot is I forgot to cube things, right? We already talked about the fact that nanometers cubed and nanometers don't cancel out, so I need to cancel them out. When I put a cubed by that and a cubed by that, I better put a cubed by everything, right? And we now know that meters cubed, even if these 2 cancel out, meters cubed and meters don't cancel out. So I need to put a cubed by those as well. And the meters cubed are on the top and the bottom, and they cancel out. Now how am I going to solve this? Well, this is going to require some more, right? Some more of what we were talking about. I have 10 to the 27th, and I'm multiplying across times 10 to the 3rd cubed, and then I'm dividing by 10 to the 9th cubed. All right, so let's look at that. You could, of course, plug this in to your calculator if you'd like to. The way you would plug it in is you would put 10 up caret 27 times 10, I wonder if you can do that. Can you do 10 up caret 3 up caret 3? Maybe. I'd put parentheses around that if it were me. And then you could hit divided by, perhaps parentheses, 10 up caret 9 up caret 3. Maybe double parentheses? That's a lot of parentheses. I would make sure you got it right. Equals. It's horrendous. Look at that. Plugging that into your calculator would suck. So let's do it a little bit easier. All right, so 10 to the 27th. Let's first multiply these out, right? So 10 to the 27th times 10 to the 3rd. We know that when we have exponents like this, we multiply them out together. So this is 10 to the 3 times 3, which is 9. And 10 to the 9 times 3, which is 27. Okay, so we can reduce this back down to 10 to the, I'm erasing as I go along here. Sorry about that. All right, let's see if I can put it on the end of the board here. Yeah, 10 to the 27th times 10 to the 9th. Ooh, I can fit it in, nice. Times 10, divided by 10 to the 27th. And you may have figured out that, hey, 10 to the 27th and 10 to the 27th, that's the same. They cancel out. But if you don't want to do that, you don't have to. You could say, you could use your exponent rules and say instead, okay, these two have the same base. So this would be 10 to the 27th plus 9 over 10 to the 27th. All right, what's 27 plus 9, right? That's 336 maybe? 10 to the 36th divided by 10 to the 27th, right? Okay, now that I have 36 and 27, then I have the same base here, so I would subtract these two. 10 to the 36th minus 27th equals 10 to the 9th, which would have been the exact same thing you would have gotten had you just crossed these two out and gotten 10 to the 9th. Okay? And indeed, that would be my answer. I would have, coming back over here, my final answer would be 10 to the 9th millimeters cubed. Kind of interesting, huh? Exponents. Exponents are super important in chemistry. They're super important in math. So please review them. This was a little bit of a complex problem, but you can use exponents in lots and lots of different places. So make sure that you're kind of thinking about it and reflecting on it and watching more, maybe Khan or something, if you need more information. All right, until next time. Adieu.